Hey there, my name's Samanvita. And you're listening to HCI Ideas. HCI Ideas is a podcast where we discuss research, receive advice, and learn about the cool things taking place at the Human Computer Interaction Institute of Carnegie Mellon University. Today, we'll be speaking with Professor Dominik Moritz about the tools he has created to increase the scale and accessibility of data visualization, even for those visually impaired. Thanks for tuning in.
Thanks so much for having me. So I'm Dominik. I'm a faculty at the Human Computer Interaction Institute at CMU, and I've been there since 2020. And I co-direct the data interaction group with Adam Perra.
Nice. So, do you think you could just talk about what got you interested in data visualization and data science?
Yeah. So I did my PhD at the University of Washington, and originally actually started out in databases, which I thought were really exciting because it was these complex systems that could do so many things, were very powerful, like had research from decades of work in them, and could run on maybe sometimes thousands of computers. But the way you would interact with them was through just a very small, simple interface of SQL queries. And that aspect of databases, that it's very simple for a user, but there's a lot of complexity under the hood that this simple interface powers. That to me was very exciting. So I worked on a distributed database system and ended up building an interface for debugging queries. And one of the aspects there that was difficult was dealing with this large data that was distributed, or these large logs that were distributed. And I found the best way to understand it was to build a visual interface where you can use our visual processing system, which is very powerful. Right? It consists of our eyes and our brains, and they work together to really let us understand, look at patterns in very large data sets. And that to me was very exciting. So I wanted to do research in this. And then what happened was I took a visualization class with Jeff Hare and did not too poorly in the class, and especially when he showed one research work that he had done before, was on a system called Immense, which is essentially using some data cube optimization, so like indexing and GPU pre-computation to allow you to really quickly interact with very large data sets and essentially eliminate all delays of interactions. When I saw that, I was like, that's the kind of work I want to do. So I reached out and asked, hey, can we work together? And yeah, the rest was then my PhD work, trying to push the envelope in what we can do around large data and visualizing and interacting with large data.
I see. That's pretty cool. I tried using SQL on a database on a project once, but I did not find it very intuitive. So I think if I knew about these tools, that might have been helpful.
Mhm.
So I just want to ask, how has this field grown over time from when you were just starting out to the modern day?
Yeah, there's been lots of changes in both, right, the community, the people who are actually working on it, and the things people are working on. One change that I find particularly exciting is a recent shift towards really trying to understand how we can make visualizations accessible to everyone. For a long time, this was kind of a niche thing that wasn't necessarily discussed, where we made visualizations, but it kind of relied on people being able to see. And as a field, we kind of came to the realization that we are, through that, excluding people from participating in STEM and in data science, in data analysis. And there's been a lot of recent work on ways to make visualizations accessible to people who cannot see, for instance, or have other disabilities. And that's been super exciting to see. There's lots of cool work in that area. And what was really interesting to me was that the techniques that we've been developing for visually representing data, a lot of those principles can also apply to non-visual presentations. So it's a nice combination of both. We can use some of the things we've already learned and apply them there, but really, yeah, shifting who we're building things for.
Do you think you could elaborate on what non-visual data visualization would look like?
Yeah, there's different ways you can represent data. So one way to think about visualization is as a mapping of the columns in a data set or in a table to visual properties of a mark. So what we often call this, we call this an encoding. So you take, for instance, the day or the time and the temperature, and you can plot them on a line by putting the time on X and the temperature on Y, and that gives you a line chart. And if you have maybe data from multiple cities, you take the city column and map that onto color, and now you get two lines. So that's one way to think about visualizations, is this is mapping. But rather than just mapping to visual channels, you could also map to other channels of other marks. And these marks could be things like sound. So for instance, you could encode data using sound, which is then called a sonification, where you maybe play a sound over time that changes its pitch to represent the changing temperature. So that's one way. Another one is to support screen readers in effectively navigating dashboards and visualizations in those dashboards. So navigating between different data series, navigating between different data points, and getting useful summaries. Alternative text for images is an important one. And then there's also a lot of work around different kinds of low vision. So it doesn't have to be fully blind, but it could be figuring out ways to make visualizations responsive, where they can work with larger text easily, or on different screen sizes, right, in different scenarios, different color schemes. And I think one interesting thing about this build is it's very multifaceted. There's lots of dimensions of it, and so also thinking about, for instance, how we can make visualizations more accessible and understandable to people, to everyone.
So when you were saying that, it got me thinking that, like, thinking about the sound example where you would play like a pitch over time.
Yeah.
That method of visualization, of representing the data, is limited in the sense of you have to listen to it over time to kind of get the whole picture of it. So both in terms of accessibility, just in general, whenever you visualize data, there's always pros and cons, or you get different information from different visualizations, right?
Yes.
So how would you balance that? Like, if you're making a tool to help with that, how do you know what to pick?
Yeah, so visualizations it's a data representation, right? Data by itself, typically the data that we're dealing with in information visualization, which is tables and various sizes, they don't necessarily have, or usually don't have, an inherent representation. And so we are picking a representation of that data, often also preceded by some data transformation that maybe aggregates the data in some way. And by choosing a visual encoding, we are making choices about what is important, what do we want to highlight. So yeah, you're absolutely right. Making visualizations, there's no one right visualization usually. It really depends on the task and who you're designing it for and what the data is. And so you have to always consider all these aspects, which is what I like about visualization. It's kind of this mix of hardcore computer science, graphics, data processing, and human perception and design. And so that really excites me. That's like this combination. So how do we make these choices, right? What's your question? How do we make these choices of what is the right chart? Well, one is first finding out what we're dealing with. What data do we have? What's in the data? So understanding the data is critical. And what we usually do, or recommend doing, is doing exploratory analysis. So analyzing the data set, maybe visualizing it with simple visualizations, just to understand, well, what are the distributions and what aspects of the data might be important for the visualization. Second is who are we making this visualization for? So figuring that out, and then figuring out what is the story we want to tell. What aspect is really the important one for visualizing here? So how is it part of a story? And then once we have that, we can then choose an effective visual encoding. So effective meaning it is you can readily perceive what the story that this chart is trying to tell you. And there are many books. There's classes that you can take at CMU and in other schools about data visualization to learn and practice these skills of visual encoding. But there's also tools that can help you. And so some of these tools we've been working on. One tool that I worked on in grad school was Voyager, which is a data exploration tool that recommends charts or it avoids the tedium of manually creating charts by letting you browse different design alternatives. Also developed an engine that can power recommendation systems like this called Draco. And then at CMU, we took this and developed a new version, Draco 2, which is more scalable, flexible, easy to use. And yeah, that's been some of the work in this area of recommendation that we've been working on. And then with my student Will, who's a PhD student at CMU, we've been looking at ways to recommend charts, not just based on the data, but also the analysis history of what you've looked at before, which can help you tell you something about the data that might be important. And so these systems can then give you better chart recommendations.
Mm-hmm. And were these systems designed for any specific kind of data or data set, or is it like how broadly applicable are these tools?
Yeah, well, usually the tools that I was building in grad school and continue to build, or we're continuing to build in my group at CMU now, are intended to be generic visualization tools. So not specific for a particular data set. We usually aim at relational data, so something that fits into tabular format. Although we have also recently looked at textual data, and I've also explored before networks and other kinds of data. But typically, tabular data where you have columns and many rows and potentially billions of rows, and that's where a lot of scalability work comes in that we've also been doing.
Right. So I think we're going to dig a little bit more into your specific work. So you mentioned Draco,
Mhm,
and I saw you also worked a lot on Vega and Vega Lite.
mhm.
So just briefly, do you think you could explain these tools?
Yeah. So Draco was this recommendation engine. Vega and Vega Lite are declarative visualization libraries. So the idea is that as a developer designer, you specify a chart by describing what you want the chart to be. And you describe it using this mapping approach that I described earlier, where you say, I want these properties of my data to be mapped to these visual properties, like the position or the size or the color of a particular mark, which could be a bar, a line, an area, a point, or one of many other shapes. And what the library then does is it renders a chart on the web in SVG or Canvas, which are two ways to visualize or to render data on the web. One is a vector based format, the other one is a pixel based format. And it takes care of giving you good defaults for the choices of for instance, the colors or the sizing, and also automatically creates axes and legends, which help you actually understand how this mapping works and what is being mapped to what. And it also provides automatic accessibility out of the box to some extent. So there are automatic descriptions, for instance, of the axes that are accessible to screen reader users. So if you navigate over a Vega Light chart with a screen reader, you can get a description of the axes. And then also, if you go over the data points, a description of each of the data points. So that's what these libraries do. And yeah, they've become quite popular. We have couple million downloads a month now of these libraries, and they've also made their way into a bunch of startups and larger companies using them, as well as the Python ecosystem. So a lot of people in work in Jupyter notebooks are using Vega Lite via a wrapper called Altair. Yeah, and there's a bunch of other users, but there's websites with all the details on them. It's the high level version of it.
That's very cool. You mentioned that Vega Lite and Vega had become libraries on Python, which is cool, but I've always used like Matplotlib for all my data representation needs. Are these libraries meant to replace it, or can they work in conjunction with it?
It is a different way of charting. So, and MATLAB is great. It's been around for a while, and the the general format is a little bit more imperative compared to the declarative approach of Vega Lite. So certain charts can be maybe more concise in Altair compared to Matplotlib. I've recently seen some numbers of how popular Altair is now. It was, I think, the second most downloaded visualization library after Matplotlib. So give it a try and see how you like it. I would say some of the biggest advantages are one that it's this more high level declarative format where you can do things like just thinking about this mapping, this encoding mapping, rather than maybe more low level details that you would have to think about in Matplotlib. And the second big advantage is that the charts are rendered as interactive charts on the web. So you can actually make charts where you can have tooltips, zoom, pan, select certain data, click on data, and then have something maybe update in a different chart. And that's something that was also one of the core features of Vega and Vega Lite, having this declarative way of specifying interactions.
I see. So when you interact with the data in this manner, I can imagine that for large data sets, that might be really slow if I'm trying to like modify my visualization on the web. Is that a challenge that you had to contend with?
Yeah, that was essentially my PhD.
Ah,
Was this challenge of, well, If your data gets large, how do you deal with that, especially in a browser? I think browsers are an exciting platform to develop for, right? They are pretty ubiquitous on like most devices. There's a browser. They allow you to access things on the internet, make it easy to distribute whatever you're having to many people without them having to like download and install something that could maybe harm their computer. In this case, it's a website that's usually very very isolated in the sense that if you have a program on a website that is usually contained to that website and cannot just read arbitrary files from your computer. And yeah, so I think the web is an exciting platform, but there are certain limitations, right? The whole app basically has to be downloaded when you open the page, and that, depending on your download speeds, could be slow. So you want to develop techniques where you reduce the amount of data that needs to be downloaded. So that's one thing. And the second thing is that the updates to any data might also be slow because of latencies, where you're making a request from your browser to some server, and there's a latency between that browser and the server, and that latency can be much higher than what's perceivable and much higher than what would affect our ability to effectively use an interface. And so yeah, and so there's a couple challenges that you need to address, and typically the way you address in problems around this scalability issues are to use aggregation, so reducing the amount of data that actually gets sent by maybe simplifying lines, by aggregating data and summing it up, or computing averages of data in certain areas. And for fast interactions, there's a couple techniques to use. Some of them include prefetching of data that might be needed in the future. So figure out maybe a model of the user of what they might want to get in the future, and then rather than waiting for the user to actually request that data, have it ready, like prefetch that. And the second is to create data structures that allow you for very compact representations of maybe a large space of possible interactions. We call these indices. A lot of database techniques actually come in there. And so that was the interesting part for me when I worked on this, that a lot of things I learned from focusing on databases, that I could bring those things I learned into my work. And so I recommend to anyone, always, you've learned something in the past, see whether that maybe applies, and combining different areas of research often leads to new insights. And yeah.
So one more question in this area. What would the quote unquote holy grail of data visualization software look like, do you think? Like one that strikes a balance between lots of interactivity, but it's also simple for the user, et cetera, et cetera.
That's a good question and a hard question. I don't know whether that exists really, because there are so many different constraints that people work with and different scenarios where I don't think there is a one size fits all, right? Like it could be depending on the data or kind of story that you want to tell, that there's a very different visualization. If you're making a visualization for a book printed, that might look very different from a visualization that should work on a website, or a visualization that you're making for your own data analysis. And in the midst of analysis, where you just want to be able to get a result very quickly, but you don't necessarily need to customize every little detail and the little font of it. Or you're making visualization for a paper where integration into LaTeX is all of a sudden very important, and embedding fonts and something like that. Or you're making a visualization that is maybe in an app on a phone, and now you need to work with the constraints of that ecosystem in that environment. Or yeah, you're making visualizations for a display that is the size of a wall or the size of a watch on the wrist. These all these different constraints of like just the environment, what you want to tell, and who you're making it for, I think creates such a big design space that is too large for a single tool to really cover. Having said that, though, I think there's a lot of things a lot of principles that apply broadly. So this principle of visual encoding, so for instance, I think is, and thinking about declarative visualization, I think is a flexible approach that allows for different levels of abstraction, where you might come in and go very high level of just here's what I want, very high level, just I don't want to bother about the details of the axis, just render it. You might go in a little bit lower, where you describe more of the details of the axis. and customize the chart that way.
All right. Let's pivot a little bit and talk about your work with the data interaction group.
Mhm,
Specifically, I want to talk about interpretable machine learning.
mhm.
Could you just tell us what you guys have been doing in that area?
Yeah, so we've been mostly focusing on, I guess, the data aspect of machine learning, not so much on like models directly. So in this area of data, if we think about machine learning, what is a machine learning model? It's a program, but it's also the data that was used to actually train that model, and the data that used to train the model can affect or really determine how this model behaves. And I think that's true now more than ever before. I think a couple of years ago, where a lot of models were much simpler architectures, often the choice of the algorithm that you use was a very important choice, like whether you use an SVM with a linear kernel or a quadratic kernel or a much more high dimensional kernel or a trees boosted tree model. Those choices really affected the performance of your models. And obviously, data was also then important, but it was often also much smaller. So you had to play a lot of tricks to figure out how to best build a model with the amount of data that was available. And then as data for machine learning grew and models became more complex, there was a shift, I think, towards data becoming more important. With deep learning, we started having these convolutional neural networks that could maybe detect what's in an image. And often people didn't even train a model from scratch anymore, where they maybe started using some off-the-shelf model that could detect objects. And then they started from that and maybe trained a little bit of an additional model to do the specific object detection for the objects that they cared about. But they didn't necessarily retrain everything. And well, now with AI, large language models, whatever you want to call them, there's been even more of a shift where you all of a sudden train models on all available data that you can get your hands on. And certain tasks you can just complete by just asking the model to behave in a particular way. Obviously, there's still also some of the adaptation and retraining and so on happening, but in many cases, the model architecture is not what matters anymore, but really the data that you feed into these models to maybe adapt them to a specific use case. And so understanding data is crucial. It's kind of the end of the story here. But so how do you deal with understanding these large data sets? How do you slice and dice them? And depending on your data set, like if it's, for instance, a large text data set, how do you get an overview of what's in your text data and maybe understand what the limitations of that data are or problems with the data that would make it maybe, or part of it, not the right fit for training a model for your task.
Mhm. So, what specific work do you do with trying to figure out like what data to feed in?
It's mostly providing fairly generic tools, so right, visualization libraries to quickly get an understanding of, for instance, what's in your data. So one of the tools that we've been working on is a tool called Autoprofiler, which is a Jupyter notebook extension. And what it does is that it continuously watches what variables you have in your notebook, and if one of those variables is a data frame, so a table-like thing, then it will automatically give you an overview of what's in that data set and give you small little visualizations that show you the distribution of the different columns. And that's super useful because as you're maybe filtering your data, slicing your data, you want to continuously confirm that your assumptions about the data are still holding true. And so by having these visualizations continuously update, we believe that it makes it less likely to overlook important changes in the data. So that's one thing. The other tool that we've been working on is more in the direction of text data. So if you have a large text data set, how can you get an overview of what's in that data set, or maybe derive new columns, derive new data from this text data that gives you a way to then maybe slice that data into particular ways. Right? One problem with text is that a text field by itself is often unique. So if you, let's say, you have a data set of restaurant reviews in a city, hopefully every review is unique. So if you just look at like a distribution of the reviews, there will just be a flat line because they're all different. So not very useful. So you have to start thinking about, well, depending on the task again, what is maybe information that about these reviews that's interesting. So maybe like the length of the review. Okay, cool. We can look at that as a distribution. Or how many sentences is there? How often does it mention a particular word? Or how is it a positive or a negative review? Does it mention a particular category of thing, like a restaurant or a sports venue or a park or a school? And you might want to group your reviews by that. And so being able to do that quickly is, and in a way where you can then, for each of the subsets, get a quick understanding of what's in these subsets. That's a tool that we've been working on, for instance.
Can I jump in here really quick with a question? I know that's like machine learning and all that's like very much a buzzword right now, and like I think the public's conception of machine learning has kind of stagnated at this very machine learning is still very much like I think a mysterious concept to a lot of people. Would you say what you're doing in your lab is part of a much bigger initiative into taking away that mysterious thing that's going on, like this black box where nobody knows what's going on, and making it more understandable, I think, to everyone?
I think that visualization can play a role in, and I think it's core to this, being able to understand data and uncovering how models behave. I think it would be overclaiming if I said that we in my group are really pushing the envelope on that right now. It's something I definitely would love to dive more into.
Yeah, I've been watching videos on like AI safety, and I guess a big deal is that we don't know what the models are thinking. So we don't actually know if they are aligned with the same goals we put into them, or if they're just kind of matching heuristics, which could be dangerous.
Yeah, and I think for AI safety in particular is something where the these models are often so complicated that it's even mysterious to experts working in the field. And so equipping them with good tools is very important. And I think visualization is a key tool there in the toolbox of anyone looking at data and models, especially these like large models, to make them more robust.
Sure. All right. I'm going to pivot a little bit now and just talk a bit about your research and as part of industry.
Mm-hmm.
So, if I'm not mistaken, you currently work at Apple as well as being an assistant professor?
Yes, so I manage this was since 2019. I've been at Apple and managing for a couple of years now a group on visualization in the machine learning organization. So we help with tools and methods for machine learning scientists at Apple to better understand the data that goes into the models there. We've been also working on visualization libraries, so taking some of the insights from the research on Vega and Vega Lite and developed a visualization library for the Apple platforms.
I don't know if any of this is under like company policy, but could you tell us where this sort of shows up in the Apple products or the Apple backend?
Yeah, so this library called Swift Charts. It's actually a library that we talked about in public. So any app developer on the Apple platform, so iOS, macOS, watchOS, and so on, can use this library to put charts into apps. It's also used for charts in existing apps or new apps that Apple itself releases, and it's also used for internally for like debugging models and things. We also do a lot of research, so we have awesome interns and publish papers, and whenever that's done, we publish those. So they are at like Kai and Viz. You can find them on the internet. So we have a couple of papers on different tools for analyzing data and looking at models, or studies on how, for instance, machine learning scientists are taking models that are very, very large and compressing them so they can fit onto a smaller device like a watch or a phone.
Right. Okay, this question is a bit more about like the industry and your experience more than the research itself, but
Mhm.
having done research both as part of the university and as part of like a corporate industry area, like is research in those two fields different? And if maybe someone's wanting to go into research, should they consider whether they want to go into like university academia or working as a research team as part of a company?
Yeah, I think everyone should consider both as options. I would say probably the individual differences are very large. So doing research in academia can mean many, many different things, and there's many different ways in which you could do it. And similarly in industry. So for me itself, like the difference might be very different for someone else.
Do you think you could speak to the difference that you had just to get a sense of one way?
Yeah, so one difference that, it's many differences, but one thing I really appreciate about working at CMU is that I can mentor students and really see them throughout their whole like path from an undergraduate or to becoming a researcher that comes up with research ideas and evaluates them and talks about them and publishes them. So seeing this like the whole path there. And teaching, I think, is exciting, being able to take the latest research or even fundamental understanding of how, for instance, visualization works and explaining that to the next generation of like tool builders and designers and engineers who then go out and actually build really cool things. And it's super rewarding to have students reach out after a couple of years and be like, oh, I took your class and I'm doing this now, and I'm applying what I've learned there, and that's super rewarding. I also enjoy working in industry. I have an amazing group there of researchers and tool builders, and we've been able to build libraries that are now on billions of people's devices. So like your iPhones are running the code that we wrote, and that's pretty cool. And so these like different ways to have impact in the world have been pretty exciting to me.
It's very interesting to hear. All right, so running out of time, so just one last question before we leave, and that's we've had 30 years of development in HCI and data visualization so far at CMU. What do you think, you personally, what do you think the next 30 years of data visualization or HCI in general might bring?
Well, Alan Kay said the best way to predict the future is to create it. It's going to be exciting. It's going to be interesting. There's going to be lots of things happening. I don't know exactly what it's going to be like. But if I knew it, I would work on what's like in 31 years rather than like over the next 30 years. Because I think as researchers, we always want to look beyond the horizon of what is kind of obvious. And I'm hoping actually that HCI research in particular, over the next few years at least, goes beyond thinking about, well, just put AI into everything, but like think things like deeper levels of how exactly are we going to interact with this, and maybe what's next. Like if these models are getting better, like where do we go from there, and how do we make sure that we still have a equitable society and in which we can grow and learn. I don't know. I don't have a super deep answer here, I guess, to where I think HCI is going to be or where it's going in 30 years. But I'm hoping to be a part of it, and I think the HCI is going to be a big part of that, shaping that future and working with other institutions around the world, creating awesome new researchers who are going to go on and do cool research in other places.
Well, I sure hope so, at least. All right, so I think that's all the time we have. So, Dominik, thank you so much for sharing your insights and your experience with us today. We've linked several of his papers, projects, and his website in the description below for anybody who wants to learn more and check out his work. Thank you for Dominik again, and thank you for listening. We'll see you next time.
Awesome. Yeah, thanks so much for having me. And
HCI Ideas is a podcast celebrating the 30th anniversary of Carnegie Mellon's Human-Computer Interaction Institute. If you've enjoyed this episode, please be sure to follow us and recommend it to your friends. We'd really appreciate it. To learn more about the research done at HCII, our friends have created a website showcasing the papers we talked about today, as well as many more. You can find this at www.hcii30.com. That's 30 with a 30. We just think it's so cool. Thank you for listening to HCI Ideas, and we'll catch you next time.